Hey guys, this video is going to cover the study guide for our test for Unit 4, which is over functions and sequences. I'm going to go through each one of these problems, so if you want to follow along. The first few problems say to determine if the following relations represent y as a function of x. So we just want to tell if it's a function or if it's not a function, okay? So the first one is a graph. The way that we can tell if a graph is a function or not is by using the vertical line test. So basically, if you have, vertical lines drawn all the way through your graph, you want to see if the graph crosses that vertical line more than once, okay? So for instance, say I drew a vertical line right through here, right? This graph would cross it more than once, which makes it not a function, okay? If it crosses it once, that's fine, but as soon as it crosses it more than once, it's no longer a function, so not a function. This next one is called a mapping. In a mapping, the x's are always on the left side and the y's are on the right side, unless they tell you otherwise. In order to tell if a mapping is a function or not, the x's just cannot repeat. Okay, so if you look through here, the 4 is being used once, the 6 is being used once, so is the 8, the 12, and the 14, and none of these numbers repeat. So this would be considered a function. All right, number 3, we have another graph, but this is called a discrete graph where it's just points, not connected. You do the same thing though. You follow that vertical line test. So if you drew a vertical line through this point right here, there's no other point on that vertical line. So far it's a function. But then if you go over to right here, if you notice, if I draw a vertical line right there, you see 3 points all on the same vertical line. Okay, that makes it not a function. Okay, number 4, here we have a table. All you want to do is check the x values. So as long as they don't repeat, so -2 is only used once, 0, 2, and 4, none of these repeat, that makes it a function. Okay, and then number 5, same thing, we will look at the x values. I see here I have 2 -1s, right? So it looks like they're repeating. As long as the y's aren't repeating as well, this is not a function, okay? So they use the x value -1 more than one time, so it's not a function. Okay, number 6, it asks which of the following sets of ordered pairs represents y as a function of x. So same thing, we want to see if any of these sets of ordered pairs are a function or not. So if you remember, in an ordered pair, the first number is x and the second number is y. So you just want to go through and check all the x values. So if the 1 is an x value, the 1 is an x value, and the 3 is an x value, we see that the x repeats, which makes this first one not a function. I'm just going to X it out. The second one here looks like I have a 1, a 2, and a -2. None of those repeat, so I'm going to put a little check mark because that is a function. Number 3 says the x value is 1, 2, and 3. So those x values do not repeat. It is a function. And then the fourth one, I have 1, 2, and 2. So the 2's repeat, which makes it not a function. So it looks like these two middle terms, these two, those are both functions. So if you look at your answer choices, the ones, I guess it would be C. 2 and 3 are the only ones that are functions. Okay, number 7. A function contains the points -9, 2, 0, 6, 1, -2, -3, 6. Which of the following points cannot also be in the function? So cannot be in the function. So far, let's see if this is a function. So if we look at the x values, -9, 0, 1, and -3, none of them repeat. So right now it's a function. And they're asking if I was to add one of these points in, which one would make it basically not a function, right? So which one could not be added in here in order for this to still be a function? So let's look at A. If I added this point in here, the x value 4, do I have another 4 in here? No, so that point would work. It would create a function, right? But I'm looking for the one that cannot be added in there. So let's not add A. Let's look at B. This one has an x value of -1. If I look through here, this would still keep it a function. That's not what I want. Let's look at C. The x value is 1. If I look through here, I already have a 1x value. So if I added this point in here, it would be a repeating x, which would make it not a function. This is what I want. Okay, let's just check the last one just in case. This is the x value 8. I do not have an 8 value, so this would keep it a function. This is not what I want. Okay, so that's function, not a function. Now let's look at function notation, which is something we went over last week. Okay, so function notation is whenever you see this little f of x or h of x or g of x or p of x, any of those letters out there. Okay, it's just a special way to name these functions. So it says if f of x equals 6x minus 4, find the value of x when f of x equals -16. So the way to remember these types of problems is they're saying that f of x is this, and they're also saying that f of x is this. So if these are both f of x, they must be equal to each other because they mean the same exact thing. They just look a little different. So if they're equal to each other, set them equal to each other. We would take 6x minus 4 and set it equal to -16. They must equal each other because they both mean the same thing. And now what it wants you to do is find the value of x. Well, 6x minus 4 equals -16. You can solve this for x. You can split the problem down the equal sign and then isolate the x, solve for x. You would move the 4 first. We would add 4. -16 plus 4 is -12. Bring this 6x down. Then you would divide by 6. So we would have x equals, and then -12 divided by 6 is -2. So the value of x would be -2. Okay, let's look at number 9. Number 9 says if h of t equals -3x plus 7, I think there's a typo here. I think this is supposed to be an x. So if h of x equals -3x plus 7, find the value of x when h of x equals 49. So again, they're telling you two different things equal h of x, this -3x plus 7 and this 49. So if they both mean h of x, they're both equal to each other. So set them equal to each other. -3x plus 7 equals 49. And now we're able to solve this equation for the value of x. Split the problem down the equal sign and isolate x. Let's move this 7 first. We'll subtract 7. 49 minus 7 is 42. Okay, then we'll divide by -3. And 42 divided by -3 is -14, I believe. 2 divided by -3. Yep, -14. So the value of x is -14. All right, now let's look at 10. 10 says, given that f of x equals -3, parentheses 4 minus 5x, what is the value of f of -6? Okay, so when you see problems like this, they're not giving you two different things that equal f of x, kind of like they did in these other two problems. Instead, if you look, they're taking what's inside the parentheses and then replacing it with a number. So normally inside the parentheses is the x value, right? So if they replace it with a -6, that is their way of telling you that x equals -6. So it's kind of like the opposite of what we were doing before. They're going to give you the x value, and you just need to plug that x value in and simplify the equation, okay? So if they're telling us that x is -6, let's take this equation here that they gave us, and let's plug in -6 wherever you see x, okay? So I'm going to rewrite this. But everywhere I see an x, I'm going to put a -6. Okay? And remember that when you plug in numbers like this, anytime you plug a number in, you put it in parentheses. So this x that I'm plugging in right here, making sure I put it in parentheses like that. And if you notice, I didn't change anything else. All the other parentheses stayed exactly where they were. I just plugged in that -6. So this side is basically just the name of the equation. We just need to simplify this. You can type this straight into your calculator just like you see it, and it will give you the answer. So if I type in -3, parentheses 4, minus 5, then I have parentheses -6, and then I have 2 closing parentheses. Gives me -102, okay? So f of -6 is -102. So this would be my answer. And this is saying when x is -6, the value of this equation is -102. All right, let's look at 11. It says if p of x equals 2 parentheses x squared minus 5 minus 3, what's the value of p of 9? So this is the same type of problem we just saw. The x is supposed to be inside this parentheses, but they replaced it with the number 9, which is their way of saying that x equals 9. So they want us to take this equation, and anywhere you see an x, we are going to plug in this 9, okay? So p, this x is going to become 9, equals 2, and remember what I said, anywhere you see an x, you're going to plug that number 9 in, but remember that you always put it in parentheses when you plug in numbers. Okay, all right, so I have this. This is just the name of it. So I'm going to type this in my calculator just like I see it. All those parentheses that I see, just where I see them. Okay, so I have 2 parentheses, parentheses 9, close my parentheses. Then I have the squared. Then I have minus 5, close my parentheses, minus 3. 149. So P of 9 equals 149. When x is 9, the equation is 149. All right, number 12. If 7 is an element in the domain of f of x equals -3x plus 4 over 3, what is the corresponding element in the range? Okay, so if you remember, we went over these words right here, the domain and the range. Those are just fancy words for x and y, okay? So if we reread this, instead of using domain and range, using x and y, it says if 7 is an element in the x, so if x is 7, with this equation, what is the corresponding y in that equation, okay? So they're telling us what x is. They're telling us that x is 7. So here's our equation. See these x's in here? They told us that x is 7, so you can go in and plug 7 in wherever you see an x. All right, so let's try that. So we have f of 7 equals -3. I see an x there, so I'm going to put it in parentheses and put a 7. Plus 4 over 3. Okay, so I'm going to type my calculator. When I have fractions like this, the best way to do it is just type in the top and then divide it by the bottom. So I'm going to type in -3 parentheses 7 plus 4. And then I can divide that by 3. Ooh, and I get this ugly decimal number. Okay, so I don't want an ugly decimal number. I'm going to change that to a fraction by pressing math, enter, enter. So -17 over 3 would be my answer. So f of 7 equals -17 over 3. All right, so it is asking what the corresponding y value is. So we know that x is 7, so then the y value is this value, this -17 over 3. Okay. All right, number 13 says a shoe salesman determined the annual profit in dollars from selling shoes using P of N equals 45x. And it looks like we got another typo here. I think these x's are supposed to be n's. Okay. This letter in here is always the letter that's in the equation. So if you ever see that, it's probably just a typo. So I apologize for that. These are supposed to be n's. Okay, so 45n minus 0.07n squared, where n is the number of shoes sold. What's the annual profit if the shoe salesman sells 435 shoes? Okay, so we have this equation. I know that the n all the way through here is the number of shoes sold, right? And it tells me how many shoes were sold, 435, which means I know what n is, which means I can plug in anywhere I see it. I can plug in the 435 in this spot this end spot, and this end spot. So let's try that. We'll say P, we're gonna plug in 435 right there, equals 45. I see another N right there, so I'm gonna plug it in again, in parentheses, then minus 0.07. See another N, so parentheses, 435, and then I see a squared. Okay, here's my name of the equation. So now I'm gonna type this in just like I see it. I have 45, parentheses, 435, minus 0.07, parentheses, 435, close my parentheses, and squared. So 6,329.25. Okay. So whenever the salesman sells 435 shoes, his annual profit is this much, $6,329.25. Okay, so that would be my answer. All right, let's take a look at the back. Here we have some sequence problems. All right, so number 14, it wants us to find the missing terms in this sequence. So I need to figure out what the pattern is so that I can continue it. So if I'm looking at 63 to 46 to 29, it looks like it's decreasing. So I might be subtracting some number all the way through here. So let's take a look. Let's see if we can figure out what that number is. So let's see. If I said 63 minus 46, it looks like there's a difference of like 17 through here, right? So I might be subtracting 17. So let's see if that works from 46 to 29. 17. Yep, it does look like that's my pattern. So I'm subtracting 17 each time to get to the next term. So let's figure out what that next term would be. 29 minus 17 is 12. Let's check and make sure that's the same thing. So 12 minus 17 would be negative 5. So far, so good. Then negative 5 minus 17 is negative 22. And then negative 22 minus 17 would be negative 39. So that would be that sequence. Okay, let's look at 15. Same thing, find the next three terms of this sequence. So it goes from 1/5 to 1 to 5 to 25. So it does look like it's increasing, but it's increasing pretty quickly. It went from a fraction to 1, and then 1 to 5, and then 5 all the way to 25. So when it increases rapidly like this, it's probably because they're multiplying by some number, okay? So the best way to figure out what number they're multiplying by is take one of the terms and then divide it by its previous term, okay? So we can take 1 and divide it by 1/5. So 1 divided by 1/5 looks like 5. So maybe we're multiplying by 5. Let's see. If I multiply this by 5, I get 1. If I multiply that by 5, I get 5. 5 times 5 is 25. So it does look like I'm multiplying by 5. So let's just continue that pattern. So if I take 25, multiply it by 5, that gives me 125. Let's do it again. 125 times 5 is 625. 625 times 5 is 3,125. Okay. All right, number 16, find the missing terms in the sequence. It looks like it went from negative 16 to negative 4 to blank to negative 1/4 to negative 1/16. So this is dropping pretty rapidly too. So let's see, it's probably multiplying by something. So take one of the terms and divide it by its previous term. So take negative 4, divide it by negative 16. And so 0.25 is probably what I'm multiplying by. So let's continue that. Let's multiply all of these by 0.25 to see if it continues that pattern. So if I take negative 4 and multiply it by 0.25, it gives me negative 1. And let's just check to make sure. If I multiply negative 1 times 0.25, does that give me this negative 1/4? I can change this to a fraction. Yes. Okay, so then let's multiply negative 1/4 times 0.25. Math enter. 1/16. Okay, now let's take negative 1/16 and multiply by 0.25. Math, enter, negative 1/64. So that would be that last one. All right, 17. Looks like I have a pattern here. I'm going from negative 21 to negative 14 to negative 7. So I know my numbers are negative, but I am increasing. If you look, remember that on the negative side of the number line, the numbers, if they're increasing, the numbers are actually getting smaller, okay? So what number would I add to negative 21 to get to negative 14, and then negative 14 to negative 7, and so forth, right? Looks like maybe a 7, right? So let's check. Negative 21 plus 7. Yep. Negative 14 plus 7. Yes. So negative 7 plus 7. That would be 0. And then 0 plus 7 would be 7. And then 7 plus 7 would be 14. So that would be my next three terms. All right, 18. It says a sequence can be generated by using this formula, a sub n equals a sub n minus 1 minus 4, where a sub 1 is 2 and n is a whole number greater than 1. What are the first three terms in the sequence? So we just want to create a sequence with the first three terms, right? So here's our formula. Remember that in a formula, don't let it confuse you too much. Try to pick out what you know. If you remember this right here, anytime you see a sub n minus 1, this just means previous term, okay? So if you know the previous term, you can just plug this in straight for this whole piece. All right, so then it says a sub 1 is 2. So that means my first term is 2. So if I want the first three terms, I already have one of them. It's 2. So if a sub 1 is 2, I just need to find a sub 2 and then a sub 3. Okay, so I'm gonna use this formula. It says to take the previous term minus 4. All right, so I'm working on the second term. So the second term is the previous term minus 4. Well, the previous term to the second term is the first term. So this would be the previous term. All I have to do is plug it in for this spot. Then minus 4. Well, 2 minus 4 is negative 2. So the second term would be negative 2. Let's find the third term. Same thing, it says take the previous term and subtract 4. Well, the previous term to the third term would be the second term. So this is the previous term. So you plug that in and minus 4. Negative 2 minus 4 is negative 6. So here are my first three terms. Okay, all right, look at 19. A sequence can be generated by using the formula a sub n equals 5a sub n minus 1, where a sub 1 is 4 and n is a whole number greater than 1. What are the first 5 terms in this sequence? So they want us to find a1, a2, a3, a4, and a5. All right, they already gave us a1, it's 4, and they gave us the formula here. So let's work on the second term. So a sub 2 is 5, and then again right here, I noticed this right here just means the previous term, right? So it looks like I have a 5 times the previous term. So what is the previous term to the second term? The first term. So you plug this in. 5 times 4 is 20. So the second term is 20. All right, let's see the third term. Same thing, we take 5 and we plug in the previous term. Well, the previous term to the third term is the second term. So we plug in 20. 5 times 20 is 100. So that's our third term. Okay, let's look at the fourth term. Same thing, 5 times the previous term. Well, the previous term to the fourth term is the third term. So we plug in the 100. So if you're noticing, each time I get an answer, I use that answer in the next term, right? So 5 times 100 is 500. That's my fourth term. Okay, and then the last one, fifth term, would be 5 times the previous term, 500. So that's 2,500. So there's my first 5 terms. Okay, all right, number 20. Says a pattern of numbers is shown below. Here we have a pattern. The pattern continues. Which expression can be used to find any nth number in the pattern? All right, it gives you the little formula that you need to create an equation for this. Like it'll end up looking like one of these answer choices. So let's take a look at the sequence of numbers I have here. It looks like we're increasing, right? So I'm probably adding something. So to get from negative 0.6 to positive 0.6, and then from positive 0.6 to 1.8 and 1.8 to 3, I'm adding some number, okay? So if I take a look at, you can choose any one of these sets just to see. What number did I add to 1.8 to get to 3? I can subtract those and it should give me the number. Yep. And you can just go through and check and make sure. So 0.6 plus 1.2, that gives me 0.6. And then 0.6 plus 1.2, it gives me 1.8. 1.8 plus 1.2 gives me 3. Okay, so 1.2 looks like the number that I'm adding through here. So we're gonna call that my D. My common difference is 1.2, okay? All right, so here's my formula. I can find any term if I take the first term and add parentheses n minus 1 and then put the D, okay? So I'm gonna go ahead and put this together. My first term in this sequence right here is this first one, right? Negative 0.6. Then it says plus parentheses n minus 1, and then our D. Well, we already determined our D was 1.2. Now, do remember this. This D does not have to be behind the parentheses. It can be in front of the parentheses. It's completely up to you. It was just the way that this was written, but sometimes it's written with the D in front. That doesn't make a difference, okay? All right, let's just simplify this. First thing I see is parentheses. So I'm gonna take the number directly on the outside here and distribute it. 1.2 times n is 1.2n, and 1.2 times negative 1 is negative 1.2. All right, I'm gonna bring this down, I'm gonna bring this down. All right, I'm looking through here and it looks like I only have one term that has an n, this one right here. So 1.2n, but these two are both constant. So I'm gonna combine those together. I'm gonna say negative 0.6 plus negative 1.2 is negative 1.8. Okay, so this should be my formula. So if you look through your answer choices, you should see one of them, answer choice B, that looks just like that. So this would be the formula you could use to create this sequence. All right, almost done. Number 21, same thing. I have a pattern here, 5, negative 3, negative 11, negative 19. Based on this information, which equation can be used to find the nth term of the sequence? Okay, so I want to create another equation like this. So I need two things. I need to know what the first term is, and I need to know what the D, the common difference is. Well, the first term looks like 5. And then what pattern is happening here? It does look like they are decreasing, right? So subtracting something. So what would you subtract from 5 to get to negative 3? Okay, well, 5 to negative 3 would be 8, right? And then negative 3 to negative 11 would be subtracting 8. Negative 11 to negative 19 would be subtracting 8. Okay, so it looks like our common difference is negative 8, minus 8. All right, so let's use this formula again. I can find any term if I take the first term, which is 5, and I add parentheses n minus 1, and then my D would go right there. All right, so I want to distribute first my D. Negative 8 times n is negative 8n, and negative 8 times negative 1 is positive 8. Bring this 5 down, and then I just want to simplify this. I have one term that's n, it's this one, so that's going to stay negative 8n. But then these two are constants, they can be combined together. So 5 and 8 make 13. So this is your formula. So looking through your answer choices, looks like D would be the best answer. All right, 22 says find the formula for the nth term of the sequence that begins 5, 25, 125, 625. Assume the first term corresponds to n equals 1. So they give us the formula here. So I need two things for this one. I need a sub 1, and this one has r. If you remember, the d was for arithmetic sequences, when you're adding or subtracting to get a pattern. R is when you're multiplying. So our sequence is probably geometric, which means I have some number that I'm probably multiplying from one term to get to the next term. So let's look at the sequence. What do I multiply to 5 to get to 25? And then from 25 to get to 125, and from 125 to 625, okay? The best way to figure this out is take one of the terms and divide it by its previous term. So if I take 25 and I divide it by its previous term, 5, it looks like I'm multiplying by 5. So my r would be 5. Okay, my first term in this sequence is also 5. So I have the two pieces that I want. I just need to put it into this formula. So I take a sub n equals a sub 1. Well, a sub 1 is 5. And then it says parentheses around r. R is also 5. And then as an exponent, n minus 1. And with geometric sequences, that is all you have to do. You don't have to simplify it any. You just plug those numbers in and that's it. All right, and the last one, number 23, that wants us to find the fifth term of this sequence. So it has the first term, the second term, the third term, and we want to find the fifth term. So we want to find the fourth one and then the fifth one, and that's going to be our answer. So let's figure out what the pattern is here, and then we can apply that pattern to create the next two terms. So it looks like I'm maybe decreasing and then I'm increasing. So probably geometric. I must be multiplying by something. So the best way to figure this out is to take one term and divide it by its previous term. So let's take negative 1/4. Negative 1/4. And we'll divide it by its previous term, 1. And then math, enter, enter. So that must be our pattern. We must be multiplying by a negative 1/4. So if I multiply this by negative 1/4, and then multiply this by negative 1/4, and then multiply this by negative 1/4, and again, I should get my last term, the fifth term. So let's take this 1/16 and let's multiply it by negative 1/4. So 1/16, and we're going to multiply that by negative 1/4, just like that. And I'm going to go ahead and change that to a fraction. Math, enter, enter. Negative 1/64. Okay, that's the fourth term, but I want the fifth term, so I need to do that one more time. Now I'm going to take that answer and I'm going to multiply it by negative 1/4. So negative 1/64 times negative 1/4. Again, math, enter, enter. 1/256. Okay, so that would be my fifth term. Would be 1/256. Okay. All right, so make sure you understand how to do all these types of problems. You're going to have, a problem on the test that's very similar to each one of these. So make sure you understand how to do all of them. If not, reach out to your teacher and get her to help you with them.